talk about electric potential difference. So electric potential difference is the change in potential energy of a charge Q moved from A to B divided by the charge. So it is simply the change in potential energy of a charge Q moved from A to B divided by the charge, and it is given by the formula voltage, or the potential difference, is equals to potential energy divided by the charge Q. So to understand what potential difference is, let's say we have a boy, for example, who is throwing some stones. So this boy here is throwing some stone on top of the hill, which is about 10 meters high. So as the boy throws that stone on top of the hill, that stone is going to gain potential energy. And as that stone fall back to the ground, it is going to lose that potential energy due to friction on the hill, and some of it is going to be converted to kinetic energy. So as the stone reaches the ground, its potential energy is going to be zero. So the difference in potential energy from the top of the hill, let's say A, to the ground A is what we call to the ground B is what we call the potential difference in terms of that stone. But in terms of charges, it is simply the change in potential energy of the charge Q moved from A to B divided by the charge. In my previous video, we said potential energy is equals to negative work done, which is equals to the force multiplied by the distance. And the force was QE, which is the electric force. If we divide our potential energy to find the potential difference, we said we divide by Q, the potential energy divided by Q, then our Q is going to cancel. We are going to remain with negative E multiplied by the distance, where E is the electric field. So this is the formula for potential difference. Let's look at electric potential due to a point charge. Electric potential due to a point charge. So if you have a charge, a single charge, now how can we find the electric potential difference? So the electric potential at a distance r away from a point charge Q is the work done in bringing a charge of 1 coulomb from infinity to the point r. So it is given by the formula V equals to Ke multiplied by Q over R, where K is the Coulomb's constant and Q is the charge, R is the distance. We have a point charge here, which is the charge here, and we want to find the potential at point P. So to find the potential at point P, the formula we use is simply V1, which is equals to Ke multiplied by Q1 divided by R, where Ke is the Coulomb's constant, which is 9 by 10 to the power 9, or in other books it is 8.99 by 10 to the power 9. And Q1 is the charge of the charge, and R is the distance which separates the point and the charge. Let's talk about also the superposition principle. So the superposition principle helps us to find the potential difference or electric potential difference at a certain point due to two charges. Let's say we have two charges here and we want to find the potential difference at that point. So we use what we call the superposition principle. So the superposition principle says the total electric potential at the point P due to several point charges is the algebraic sum of the electric potentials due to the individual charges. What they're saying is that to find the electric potential at a point, let's say it is P, you simply find the electric potential at that point due to this charge, and you find the electric potential at that point due to this charge and add the two electric potential, then that will be the electric potential at that point P. Let's have a problem. We see how we can utilize what we have learned. So a problem here says a 5 microcoulomb point charge is at the origin, and a point charge Q2 negative, which is equals to negative 2.00 microcoulomb, is on the x-axis at 3,0 meters. If the electric potential is taken to be 0 at infinity, find the electric potential due to these charges at point P with coordinates 0,4 meters. And B says how much work is required to bring a third point charge of 4 microcoulomb from infinity to P. So to solve this question, we are going to use these problem solving strategies. So to follow the problem solving strategy for electric potential, firstly we need to draw a diagram of all charges and circle the point of interest. Then from there we calculate the distance from the charge to the point of interest, to the point where we have been asked to find the electric potential. So we find those distances. Then from there, for each charge Q, we calculate the scalar electric potential, keeping in mind the sign of each charge must be included in the calculations. So the sign, the positive and negative charges, you include them in the calculation. And finally, you sum all the numbers found in the previous step, obtaining the electric potential at the point of interest. So you use the superposition principle to find the total electric potential. So we're going to use those strategies. We first need to draw. So we have a 5 microcoulomb point charge at the origin. So indicate that at the origin. And then from there, we have this other charge, which is Q2 at 3,0, which is at the x-axis 3 meters away. So we're going to indicate that 3 meters away, Q2 there. And then from there, the question is asking us to find the electric potential due to these two charges, which is Q1 and Q2 at point P. This point is on the y coordinate, which is 0,4 there meters. So you indicate that it is 0,4, which is 4 meters away from the origin. So after that, according to the problem solving strategy, they said you draw the diagram. After that, you find the distances. So the distance from the Q1 and Q2 to the point of interest, which is our point of interest where we want to find the electrical potential, is point P. So we find the distance from this charge to that point, and then we find the distance from that charge to that point, of which from this charge to that point we already have it, which is 4. So we're going to solve the distance from Q2 to that point there. Then from there we are going to use that formula, which is V equals to KE multiplied by Q1 over R to find the potential difference. And then from there we're going to find the sum to find the total potential difference at that point. So to find the distance, this distance here, we are going to use Pythagoras theorem, which says you simply square this and add it to this, the square of this, and then from there find the square root of the 2. That will be the distance there. So the distance there will be 4 squared plus 3 squared, which is 25, and the square root of 25 is 5 meters. So that distance there is simply 5 meters there. So after we have found all the distances, which is the distance from this to there, we already have it, it is 4. Then now the distance from this to that point of interest is 5. So let's now find the potential differences. So the potential difference due to Q1 on that point is going to be K multiplied by Q over R. And our K is simply the Coulomb's constant, which is 9 multiplied by 10 to the power 9 newtons per meter squared over per, which is per coulomb squared. Then the charge Q1 is 5. We've already been given in microcoulombs. So in microcoulombs, we simply multiply with -6. The micro there is simply by 10 to the power 6 coulombs. Over the distance for Q1, the distance is 4. So multiplying that and divide by 4 meters, we are going to have this. That is our V1 due to Q1. That is the potential difference of Q1 due to the potential difference at that point due to this charge here. And then from there, we need to find the V2, which is for Q2. So V2, again, we use the same formula, which is V equals to K Q2 over R, which is the distance, 5 meters. And then the K is the coulomb's constant, which is 9 by 10 to the power 9. And then the Q2 is the charge, keeping in mind the sign, which is negative. In this question here, it was negative there. So you leave it the way it is, a negative divided by 5. Punching this on the calculator, you're going to find that it is -3.6 by 10 to the power 3 volts. Remember, potential difference is measured in volts. So to find the potential difference at that point, we need to add using the superposition principle. You add the voltage, the potential difference due to this and that. That will be the potential difference at that point there. So adding V1 and V2, our V1, we already found that it was this one here, which is 1.313 by 10 to the power 4. You add this plus the one we found there, this one, we're going to find that our potential difference at that point P is 7.7 by 10 to the power 3 volts. So that's how to solve that question. Then from there, for B, they're saying how much work is required to bring a third point charge of 4 microcoulomb from infinity to P. So for this question, what you do, there is this formula here. There is this formula which says for work done to bring a charge from infinity, you simply multiply the Q, you multiply the charge, the third charge which is coming from infinity by the potential difference. Okay, so in this case, the potential difference at P, where that charge is coming. So it's coming from infinity to point P. That's what the question is saying. So we are going to subtract the potential difference at point P by the potential difference at infinity. And in the question, they said at infinity, the potential difference is simply 0. So here it is going to be 0. So it is going to be 0 there, and then here it is simply 7.7 by 10 to the power 3. So multiplying these two, you are going to have this, which is 3.08 by 10 to the power -2 joules, which is the work required to bring the point from infinity. So thank you very much for watching. Remember, don't forget to like if at all you like this video, and subscribe so that you each and every time I post a new video, you get a notification, and leave your comment in the comment section concerning this video.